This video is on basic atomic structure. You already know that the proton and neutron is in the nucleus and the electron is circling around the outside. So this is just a review on little basic things like that and utilizing the periodic table to get information on the atom. So again, two main parts of the atom. The nucleus is in the center and the electrons are way on the outside in something we call the electron cloud. The main thing I want you to wrap your mind around at this point in relation to the atom is just how small the nucleus is in relation to the overall size of the atom and how much empty space there is. Okay, so there's a picture here of approximate sizes, and it's really hard to understand, like, if this line is approximately 10 to the negative 10 meters and the atom is approximately 10 to the negative 15, those are proportional sizes. I'm assuming you know the proton is positive and the neutron has no charge, the electron is negative. But this is all a little confusing, so I'll give you an analogy. If you imagine a football field, okay, and you imagine the 50-yard line right smack in the middle, if you put a marble right on that 50-yard line, okay, and imagine that was the nucleus, the closest potential electron would be at the goalpost. Okay? So if that were the size of the nucleus, the closest electron would be all the way at the goalpost. And between the marble and the goalpost would be nothing. Absolutely nothing. Empty space. That is the atom. And the nucleus is so dense. Okay, we talk about density, mass per volume, right? The density of the nucleus is 1 times 10 to the 14th grams per mil. Now the nucleus is so tiny that we're talking like a fraction of a gram, right? But if we got it up to the size of a gram, 1 times 10 to the 14 grams in 1 mil. So imagine that you had pennies, okay? If we had something that was the volume of a penny, so imagine a penny, that was made up of a material that was that dense, the mass of it to get to the volume of a penny would exceed 30 million tons. The nucleus is so dense. It has so much mass in such a teeny tiny space. And that is what we are made out of. Okay? Super, super density and nothing. Okay? That's life. That is the key component of life. It's crazy. Structure of the atom. So if you look at your periodic table, it gives you all your information about the atom. Okay, I have 3 examples behind me on the board of information that would be on a periodic table. And you received a periodic table from me already. Your atomic number, which is always the whole number, okay, no decimal point, in any box on the periodic table, that will always tell you your number of protons. Okay? If we're dealing with an atom that is neutral, meaning it does not have a charge, it's not what we call an ion, then this number will also represent the number of electrons. Because if it was neutral, you need the same number of positive and the same number of negative charges. Okay? The mass number is another number we look at with atoms, and let me tell you up front, it's not the atomic mass. Atomic mass, that is something that you get from the periodic table. Mass number, you cannot get from the periodic table. What is your mass number? Your mass number is your number of protons, which is your atomic number. And then it also includes the number of neutrons. So your mass number is always protons plus neutrons for your any given atom. So how do you find neutrons then? Okay, nothing here is going to tell you neutrons. You always have to do the math. Take your mass number, take away your atomic number, and that'll get you neutrons. The proton and the neutron have the same mass, okay, in terms of grams or kilograms. It's 1.67 times 10 to the negative 27 kilograms. Okay, very tiny. Because it's so tiny and it's a crazy exponent, chemists have come up with their own unit, and it's called the atomic mass unit. 1 atomic mass unit is 1.67 times 10 to the negative 27 kilograms. Okay. Okay, so 1 AMU is another way of saying it. So for every 1 proton and 1 neutron, you have 2 AMUs. Okay? Every single proton and neutron has 1 atomic mass unit. Electrons are so much smaller, 10 to the negative 31 kilograms, that we don't even give them mass. Okay? Essentially, they have 0 AMUs when we're trying to calculate mass. So where this idea of mass number comes from is that if you know the number of protons and know the number of neutrons, essentially if you add them together, you'll get the atomic mass for any given element. So if you have 6 protons and 6 neutrons in carbon, you're going to have 12 atomic mass units, or 12 AMU, and then if you multiply that by the conversion, you could get to the actual kilograms, but usually we don't care. Okay, we're just looking for the atomic mass unit. There's 2 different ways to give you information about a specific atom separate from the table. So the periodic table, what you see on any given periodic table is an average. It's a weighted average. We'll talk about it in class tomorrow. But this is not representing any one given atom. It's giving you an average of any atom that you could encounter. On the screen here, it gives you 2 examples of ways I can give you information on one particular atom. Okay, if I want to tell you how many protons and how many neutrons there are in one atom, I can do it one of 2 ways. I can give you the shorthand notation, which is the name of the atom and then a line. Okay, so we have carbon, and then we have a line, and then it says 12. Okay, what is 12? This is the mass number. And I already told you that mass number is neutrons plus protons. Okay, so I'm giving you the mass number. I'm giving you neutrons plus protons. Another way you can show what is in any given atom is using subscripts and superscripts instead. So instead of writing carbon 12, you could do just the big letter C, which is the symbol for carbon. Up, you would put the mass number. Down, you would put the atomic number. So up, you put the mass number, and down, you put the atomic number. And why we do this is to be able to do calculations. Okay? Given the shorthand notation or the superscript subscript notation, you should be able to determine number of protons as well as number of electrons. So, for example, if we're given just carbon-12, what we know about that is 12 is its mass number. And mass number is the number of protons plus neutrons. Okay. So a shorthand, you have to do some work. You need to get out your periodic table. Because 12 tells you protons plus neutrons, but you need your number of protons to get to your neutrons. Your protons are always on your periodic table. So if you get out your periodic table and look at carbon, you can see the atomic number is 6. So if I ask you for this atom, how many protons you have 6 protons. And protons is usually just a P with a plus. How many neutrons do you have? Well, again, your mass number is protons plus neutrons. So if you take away protons from it, you'll just have neutrons. So if you take 12 minus the 6 protons, you'll get 6, and that's your number of neutrons. Okay, so this particular atom, carbon-12, has 6 protons, it has 6 neutrons, and then if it's neutral, so no charge, how many electrons will it have? It'll have the same number of electrons as it has protons to make it electrically neutral. The subscript superscript's nice because you don't need your periodic table. I give you the atomic number there, so you wouldn't have to look it up. So let's do another example. I give you these 2 up here so we can use them without having to get out a periodic table. If I said iron, (55), for example, and then I asked you, hey, how many protons do you have? How many neutrons do you have? And how many electrons do you have? you'd have to look at your periodic table. And if you look at your periodic table, you have this number 26. And that is how many protons you have. So you don't have to do any math for that one. You just have to write it down. How many neutrons or electrons do you have? Well, you can think about it. But if it's an electrically neutral atom, and I'm not telling you any different, then you can assume electrons equal protons. So that one's done. Now neutrons require a little work. This 55 again is your mass number, which is your number of neutrons plus protons. So if you take that number and you subtract the number of protons from it, you should get your number of electrons. That's using shorthand. Now, what if I use superscript and subscript? So we'll do chlorine for this one. Your bigger number, your mass number, is on top, and your atomic number is on bottom. Same question, how many protons? How many neutrons? How many electrons? I've given you protons now this time because I gave you the atomic number. If it's an electrically neutral atom, and this one is, you know electrons are the same as protons. To get to neutrons then, again, your mass number is your protons plus your neutrons. So if you take away your number of protons from it, you'll get your number of neutrons. There's no units on these. Okay, this is counting. How many are there of something? You could consider putting an AMU on it because they are equal, but that's not what we're doing. We're counting atoms. We're not doing anything with mass.